Uh, we will start with the data modeling session today. Okay, so as part of today's session, we'll cover what is data modeling, what is relationship, how to define or create relationship between tables. And previously, you all learned about how to connect various data sets using Power BI, and also you learned how to perform data transformation using Power Query Editor. Now we will see what exactly data model is all about and why we need to do data modeling, and then let's see how to create relationship between the tables. When it comes to Power BI, data modeling is very much important because Power BI filters the data based on the relationship between the tables. Without having the proper data model design in place, you cannot get the accurate result in your or accurate output in your visuals. Okay. Data modeling is an important topic, and it is the one we need to make sure that we are designing the optimal data model in order to improve the model performance, query performance, and also reduce the redundancy, all the things. Okay. First of all, we'll start with understand what is a data model. So what is a data model? Data model is something like a blueprint. Before you construct a house, you will have the blueprint in place. Without blueprint in place, if you construct a house, what will happen? The later point in time, if you want to make some alterations to your house, it can lead to a major damage to your house. For example, you forgot to keep a concealed, you don't have the provision to keep a concealed cable provision. Okay, in that case, what will happen is you need to break your house from the top floor to your first floor. Let's say you are living in a 4-storied building, and you want to have your association member, they say you are not supposed to take the cable wire from your terrace to your first floor, right? It should not dangle from the terrace to your first floor house. If you are living in a first floor flat, the cable wire will dangle. So we don't want that to happen. So in that case, if you want to keep a provision of the having a concealed pipe, you'll have to start from the fourth floor to till your first floor. So it can lead to major damage. It can cause some structural damages also. So how a blueprint is important before you construct a house, before you build any applications or any OLAP applications or reporting applications or any data warehouse applications or any products, you should have well-designed data model. With a well-designed data model, you can improve your queries performance, and also you can reduce the redundancy. Okay, so that is what data model is all about. So as part of data model, what we do is we establish or create the link or relationship between the tables. That is what we do it in short. There are three types of data model. One is the conceptual model, other one is logical model, and physical model. So as part of conceptual model, what we do is we identify all the essential entities and the relationship amongst them. For example, as part of conceptual data model, what we do is we will understand the essential entities that are required as part of your reporting model or as part of your subject area, data warehouse subject area. The customers orders product, and the products falls under different categories, and also they order products across the stores, right? So here the essential entities are like customers, orders, and products categories. High level, we should be able to high level we understand what are the entities that are required as part of a subject area. For example, you have a subject area something like sales data model. Okay, your subject area something like sales subject area. Okay, fact or internet or fact sales is a subject area. In that subject area, what are the entities that are required, which is nothing but the tables at a high level. So what are the tables that are required, and what are the business events that needs to be recorded in each entities, how each entities are interact with one another. If you look at here on the top here, so you can see the sales is the transactional table. Okay, so the different stores or each store can have multiple transactions in the sales table, and also a sales happen across multiple stores. So here many to many relationship. Okay, and product table also, many products we could see we sold it in the past, and also right in the time at different point in time, right, so one or more time we sold many transactions, many transactions happen one or more time, right. So that is what the relationship, with the relationship we can find out here. So we identified the entities first, and then we identify the relationship between the entities. So these are the things that we do it as part of conceptual data model. The next what we do is, as part of logical data model, we will define the properties of each entities. In the case of time, the properties are date and date description, month, year, all those things. And product, when it comes to product, these are the characteristics. What is the name of the product, the unit price or the cost price, when the this product got created, all those information related to product, we store it in this table. And we define the attributes, the columns, which are nothing but the columns we define each entities as part of the logical data model. When it comes to physical data model, this is where we define the foreign key, primary key, and also we specify the data type of each columns and the width of each columns. For example, your customer first name, what is the size of your customer name, right? So you are going to define physically. For example, var 2 of 50 or var 2 of 30. The customer first name is 30, and the last name is also 30, something like that. You define the product description. What is the size of the product? So you define all the data type, everything as part of your physical data model. Look here. So this is how you define. So product description varchar of 50 and category ID integer, category description you define as part of this. So as part of conceptual data model, we identify the essential entities that forms part of your subject area. So now the question is, how do I identify the essential entities? How do I identify the relationship between? So what you do is you conduct the workshop with the different line of business managers, different department. You hold a meeting, you involve all the key stakeholders, okay, manager and above is level, and also the clerical level, right? So clerical level to top level, involve them, so that you will get to know for the sales department what all the entities that are required. Okay, identify while conducting a workshop, you will be able to understand different people's requirements within that sales department, based on which you come up with all the essential entities, and then you identify the relationship between them. That's what we do it as part of conceptual role. Right. So the idea of conducting the workshop with by involving all the relevant key stakeholders, we don't want to miss out any entities, or right. So any business events we don't want to miss out. Okay, that is the reason why we conduct the workshop for department level. Okay, so that we will not be biased, we will not there will not be any rework later point. If you involve only few stakeholders as part of a sales department, later point in time you should not go back and make a changes to the table. Later point in time, if you make a changes to the data model, it is something like making alteration to your building without having the proper blueprint. Okay, that's why first you come up with the essential entities and identify the relationship, and then define all the attributes that are required as part of each and every entities, and identify the relationship. And till the physical model, once you are done with everything, each and every phase, and once you complete the conceptual data model, you share it with the customer stakeholders and vet it with them. Once they say go ahead, the next identify all these things by interacting with the business owners or business analysts, get all the list of attribute that forms part of each and every table. And finally, this is the one. Okay, so once you develop the physical data model, then the database administrator is the one responsible for implementing all these tables in the data warehouse environment. Next one is why we need to have a data models. Why do we need to have a data model? So you got a fair amount of idea of data model, the necessity of the data model. Without having the data model in place, and if you start develop your report, it can cause some major changes to your the data model design later point in time. Okay, so that's the reason why you first design your data model perfectly so that there should not be any rework. And if the data model has been designed correctly, and if that has been optimally designed, then your query performance will be good and there will not be any redundancy. And without data model in place in Power BI, you cannot filter the data. Okay, you cannot filter the data between tables. So that is the reason why data model is very much important. Learning the data model is very much important, and working in Power BI, you should be knowing how to do the data model design. So this is the typical data modeling process flow. First, we identify the essential entities, which is nothing but the tables. Okay. Next one is we identify the logical data model part. What we do, right? So that's what we do it. We identify the key properties of each entities, and then understand the relationship between or amongst the entities. Next, we map the attributes to the entities completely, and then visualize the data. Using Power BI, you visualize it. And in case of any additional keys that needs to be included, you go ahead and do it. And once you are done with your data model, then finalize and vet it with your stakeholders. Once they say go ahead, right? So everything is included, all the relationship, whatever you created amongst the tables, it's all perfect, then you are good to go with developing your reports. Before we proceed with implementing or creating a data model, we will understand what is a data warehousing is all about. First, we understand what is data warehousing is all about, because if you say you are a Power BI developer, you are part of the business intelligence team. Okay, so in that case, you should be knowing what is data warehousing is all about. Data warehousing, right? So in the data warehousing is the one will house your data model. So far we discussed about the different types of data model, and lastly we discussed the physical data modeling. In the physical data modeling, what we do is we are going to create the tables, everything in our data warehouse. We create the tables, whatever we designed it, inside the data warehouse we created. But it is not mandatory they are supposed to create everything in your data warehouse. Those cannot afford to have a the expensive data warehouse. So you can use Power BI, Power Pivot itself. There itself we can model the data, and then you can share it with your team. Okay, so we have something called Power BI data sets, right? So once you model it, right, you can share it with your team members, they can use it. But most of the cases they use data warehouse. Nowadays the data lake also gaining a lot of momentum. First, let us understand what is data warehousing is all about. Data warehousing is something like it is integrated. Look here, the data or the source data are coming from various applications, ERP, CRM, legacy, external and other source systems, we are getting it. So using using Python or any the SQL Server integration services or ADF, Azure Data Factory, what we do is we take extract all the data, and then we transform the data by cleaning the data in case of any duplicate records, or in case of any missing values, or in case of any format related issue. Everything we address it as part of transformation. You first extract the data, and then we transform the data, and then we load the data into data warehouse. Okay, so the data warehouse will is a integrated one, because we are extracting the data from various source system. It's a central repository. It's a central repository of well-structured data gathered from the diverse sources. Okay, in this case, in the case of data warehouse, the data has already been cleansed and categorized and stored in tables in the star schema or something like that. Okay, dimensional modeling, we use it to store the data here. And the next one is data warehouse historical. We store the historical data. We store the history, right? 5 years data or 6 years data, or or 3 years data. It depends on your business requirement. You determine how many years of data you store it here. But in simple term, data warehouse is to store the historical data, and also it is non-volatile. So once you store the data, it will not undergo any changes. If you want to update any columns, any records, it is an expensive process, because this whatever the table data that you store it in data warehouse, it has a large amount of data in it. Hence, in general, performing update or delete operation in the RDBMS system is an expensive process. It requires a lot of memory, okay, and a lot of IOs. So hence, once you store that, so to overcome the update activity, delete activity, what we do is we store the historical data. For example, a customer in the last year, he was living in California. Now he moved to New Jersey. So what we do is we are not going to change his address. Instead, what we do is we store his past address and current address also. Because if you have to update the customer's address, what will have is expensive process. It takes a lot of time, because we store terabytes and above volume of the data when it comes to the big box retailers, or the larger enterprises. Next one is, it is time variant. So the historical data, we keep it in data warehouse. So for example, we can retrieve data from 3 months or 6 months, 12 months. Even if you want to retrieve the older data, right, it is possible. So in contrast to the transaction system, OLTP, online transaction processing system, here we store the historical data. It's a it's a time variant one. So in simple time, data warehouse is integrated historical, non-volatile, and time variant. So time variant. So if you store the historical data, you can perform year over year comparison, quarter over quarter comparison. You can do anything, right? So that is what data warehouse is all about. Once you store the historical data, from these integrated source system, right? So what will happen is, you can generate reports. You can you can use visualization tool, or you can use the conventional reporting tool, or right. So you can use any kind of applications OLAP applications to access the data warehouse to consume the data. So what is the difference between online transaction processing and data warehousing? When it comes to online transaction processing, for example, you just think this way. The other is the e-commerce website. You are owning an e-commerce website, and customers order their products through your e-commerce website or applications, apps. All the data gets stored in the online transaction processing database. Even in the case of OLTP, online transaction processing, we do the data model design. So there are two types of systems. One is OLTP, and other one is let's say data warehousing. When it comes to OLTP, here also we do the data model design. We call that as a normalization. Normalization. When it comes to data warehousing, we do denormalization. And the difference between OLTP and data warehouse is, in the case of OLTP, we don't store historical data here. Okay, here the update, delete, performance should be much faster. The performance should be much faster. Customer should be able to raise the order, generate the order in a pretty fast manner. And if they want to make changes to their order, if they want to cancel it, everything should be pretty faster. Hence, the volume of the data is they keep it minimal in OLTP system. But when it comes to data warehousing, the volume of the data is very high because you are storing the multiple source systems data, that too the historical data, you are storing it here. Okay, in simple term, the OLTP system will have less volume of data in it. Yeah, data warehouse is also called as OLAP. Vivek asked some questions. The one online analytical processing, instead of saying OLTP, data warehousing, we can say OLAP also, online application processing system or data warehousing, right? So they call it as. So the difference between these two are pretty simple. Here we don't store the historical data because we wanted to retrieve the data in a much faster manner, and also we wanted to do the DML operation, data manipulation, like insert, update, right? So insert, update, delete, all these operations we want to see. Even in the case of data warehouse, we do insert, but we don't do update and delete. We don't do it. Okay, but rarely we do update. Okay, so but in general, it is not recommended doing update and delete on your data warehousing or OLAP system. Okay, and also here the data model, they use a technique called normalization. Here they split the data into, they store the data into multiple tables. But even in the case of data warehouse, we store the data in different tables, but compared to the online transaction processing, the number of tables that we split it here is very less. So here basically we do some kind of denormalization. For example, you have something like region, or let's say you have product table, not product table, let's take a region. Okay, region table, and you have something called region manager, right? So region manager, and his manager name is there and region is there. Instead of having it in a two separate table, you can combine it everything in a single table. Okay, or other example is like customer table is there. You have some customer table, and to store each customer's address, we use another table using customer key from this table, and the customer key from this address table, we are going to join it to retrieve the address of any customers. Okay, so in this case, instead of storing the data in two different tables, right? So what we do some kind of denormalizing. We combine the customer and their address in a single table. This is a classic example. So in the as part of denormalization, what we do is we keep these two tables in a single table. Okay, so that the number of joins that you need to do it, right, or the number of tables that you join it as part of data warehouse is very less. If you join multiple tables, that can cause a serious performance issue. So try to reduce or minimize the joins between the tables. That is the whole idea of denormalization. Next one is the data lake. We have something now, data lake is gaining a lot of momentum. So the difference between the data lake and data warehouse is, when it comes to data warehouse, we perform ETL. We store the clean data. Okay, before we load the data into your data warehouse, you do the cleaning everything and then you load it. When it comes to data lakes, ELT, you extract, load, and then you transform the data. Okay, the advantage of this one is, see here, data is transformed when it is retrieved from the data lake, right? So once you store the data here, you store all the data here, multiple source system data, or everything you store it here in the centralized place. Once you load the data here, next you start do the transformation. So then, okay, how the data lake is going to create differentiation? You might be asking this question, right? So what is so big deal about using data lake? Why can't I use this one? Or why can't I use data lake in place of data warehouse? Or can data lake replace data warehouse? Can I replace the data warehouse by data lake? Why should I have data lake and data warehouse? Or do I need to have both? Yes, you need to have both. Okay, but here what happens is, in this case, your source system is e-commerce site. Listen, your e-commerce site, customers are ordering the products across the globe. Take for example Amazon, Walmart, Target. The customers are ordering 24/7 across the globe. Already this OLTP system is overburdened, right? So many customers are ordering it. The database is pretty busy here. On top, if you extract the data from this table or database, and then if you apply the transformation on the source system data itself, you are overburdening the source system. Extracting is fine, but it's simply you are reading the data. But while reading the data, you are applying the transformation, and what will happen is that transformation will run on your source system. It can cause a serious bottleneck to your OLTP system. Instead of applying the transformation while you extract the data from the source system, first you extract the data as it is and store it in a temporary space, which is nothing but your data lake, and then you do the transformation. Once you transform the data, you can load it into data warehouse. So the transformed data can be consumed by various applications. The data lake is also a centralized repository. It allows us to store all our structured, unstructured, or semi-structured at any scale. Okay, at any scale. Okay, when it comes to scalability, it's very good. Okay, you can horizontally you can scale it. So hope you all aware of horizontal scalability, right? So as and when you think that you need to increase the storage capacity, simply plug in additional system into the existing one. That's all. You are up and running. Okay, you don't have to shut down your system. Restart your system. You don't have to. You don't have any outages here. Okay, in the case of horizontal scalability, right? So you don't need any outages. Okay, you don't have to shut down your system, and you don't have to bring up here. Okay, bring up the system. So the data lake, it will not replace the data warehouse. So these two are complementing with each other. So if you have data lake, and then from the data lake you can source the data to your data warehouse, and for other applications also you can source the data. There are some applications that doesn't require any transformation. Okay, in that case it can directly pick up the data from your data lake. Okay, and there are any operational reporting that doesn't require any transfer. The data itself clean, right? Whatever you extract, that is more than sufficient. They don't need to do extensive transformation, or if they want to do it, minimal transformation, right? They can directly consume it from your other applications. Okay, apart from data warehouse, other applications also, since we store the data in a centralized place, the raw data, it can be consumed by any application. For example, you have machine learning applications or deep learning applications. Since you can store unstructured data also, right? Anything can come and pick up directly from the data lake. It's a centralized data store. Okay, so in the data warehouse, now let us focus on the data warehouse. In the data warehouse, we do the denormalization. We perform the denormalization. As part of data warehouse, we store the data in the form of denormalized form. Okay, so in this case, what we do is we use a technique called dimensional data modeling. Dimensional data modeling is also called as a star schema. Okay, there are two types of schema when it comes to data warehouse. One is star schema, other one is Snowflake schema. The idea of this star schema is to keep all the numeric values in a separate table called fact table. So you keep all the numeric values. The reason why they call it as a fact is we keep the facts in the fact table. What do you mean by fact? Fact is nothing but measures. Measures are nothing but numeric values. For example, profit and net margin and your discount or freight charges or expenses on the sales. All these variables are quantitative in nature. You store all the measures which are nothing but the numeric values in the fact table, along with the numeric variables or variables. We store the dimension keys of other tables. So these are the dimension tables. The dimension tables are also called as lookup tables. Okay, so now the question is, what is the use of these dimension tables? these dimension tables are, these dimensions are having a relationship with, all these dimensions are having relationship with this fact table. Okay, so the dimension tables gives the descriptive information about your facts. For example, you have something like 10. In the quantity, you have something called quantity column, you have something called 10, and then sales amount, you have something called 1250. If somebody says, and also in the fact table, you have something like the key is there, product key. Where is the product? This is a product key is there. So the fact table consists of the keys of all these surrounding dimension tables and also the facts. The product key is something like P0502. For this product key, this is what the sales we made it. But if with this key, can we understand what product is that? Right. So to give the context to this sales, we store the descriptive information in the product table. This product dimension will have the product number or product key. Along with that, it will have the product name and the cost price, and then the date, the effective start date, end date, everything in it. With the help of the dimension tables, we can understand for which product how much we made sales. Okay, in simple term, the dimension tables stores the descriptive information along with the surrogate key. So surrogate is nothing but the primary key. Okay, so using the primary key, we can uniquely identify the records. For example, in this product table, I have something called the surrogate key value is P001. This is a product A, and P002 product B. For each product, we will store only one record in this dimension. All the dimension will have unique keys in it. The keys should not get duplicated, right? The duplicate keys are not allowed in each dimension key. So for example, here you have category, dimension category. You can store the category. For example, your category like appliances or apparels. Okay, this is like C01, C02. So for each category, you will have only one instance or only one record is allowed to store in this one. That's how we design it. Okay, so for that purpose only, right? So the surrogate key, which is nothing but the primary key, is used here. Okay, the dimension table will have both the surrogate key along with the descriptive information. The fact table will have the combination of all these dimension tables keys along with the facts. Facts are nothing but the numerical values like sales, gross margin, net margin, gross sales, everything. Those are the numerical values. So only when you have the keys also stored along with the facts in this fact table, you should be able to you can perform multi-dimensional analysis. For example, if somebody is asking you region wise, I want to know the sales, right, total sales by region, by category, by product. In that case, only when you store the keys along with the facts, you should be able to retrieve the descriptive information from the respective dimension tables. That is what star schema is all about. The next one is the Snowflake schema. This is an extension of the star schema. In general, star schema is the recommended one. When it comes to Power BI, when Power BI, they recommend the star schema because of the performance in all aspects. Star schema is the best one. But there are cases we will end up creating Snowflake schema. For example, you have something like the product dimension. If you look at here, all the keys are flowing down to your fact table. There is no direct relationship between the dimensions, right? So this dimension is independent of this one, this dimension is independent of this one. All the keys are, for example, you have product key here. In this table, product key, and here date key. So all these keys, from these tables are, flowing down, or using this key, we created the relationship between or amongst the between the fact table. But when it comes to Snowflake schema, you can see, we did some kind of normalization. This is called normalization. We did some kind of normalization for this dimension table itself. So in this product table, we have something called supplier ID. So here also we have supplier ID. Instead of storing for each supplier name for each product in this table, we are storing the supplier detail in a separate table. But in this case, to identify, for which product is supplied by which supplier, you need to have two different tables. Okay. So here, there is a hierarchy here. When it comes to Snowflake, there is an hierarchy here for the dimension tables. Okay, so the dimensions, right? You can see in the case of Snowflake schema, it adds additional dimensions. Usually it represents something like the hierarchies. The advantage of Snowflake schema is it uses smaller disk pages. Instead of storing the supplier name for each and every product, if you store it separately, right, you can save the storage space. For example, your product name is product key is P001, and let's say your product name is product A, and the supplier name is Jensen Associates, something like that. And then other product P002 and product B, even this also supplied by Jensen Associates, right? So in that case, every time, instead of storing the supplier name, you can say supplier ID is S01, so S01, right? So S01 will not consume much space. Okay, so what we do is, in that case, we do some kind of normalization. So as part of normalization, we decompose the tables. Instead of having everything in a single table, we decompose it. Okay, we are splitting the table in simple terms. But the advantage is it uses smaller disk space, since we are splitting and store it in a different table. It is easy to implement a dimension, right, added to the schema. Because of the multiple tables, the query performance is reduced here, right? The query performance is reduced because we don't store the data redundantly, right? So because of which also the query performance will be better. So, but when the disadvantage with Snowflake is the maintenance effort is very high, right? So because of the more lookup tables, since you have more lookup tables, that is one of the disadvantage when it comes to Snowflake schema. Next, we will hope you understood what is star schema, but in general, star schema is the most preferred one. This is the one is recommended. We'll try to denormalize wherever it is required, right? So to have it everything in a single dimension table. In the worst case scenario, we have to go for it. But even in the case of Snowflake schema, right? So we can do some kind of denormalization in the interest of reducing the number of joins between the tables or number of lookups, right? So for example, if I wanted to see the, what I wanted to see the sales we made because of so and so supplier, right? So in that case, you need to traverse through two tables. This table is not directly having any relationship with this fact table. It has to traverse through this table in order to get this one. Okay, so we'll try to denormalize that. That is, we'll do it. Okay, but in simple term, star schema is the one recommended model by most of the experts, right? They recommend star schema only. Next, we will see what is a relationship. When it comes to Power BI, relationship is filtering. Okay, filtering. What do you mean by filtering? Filtering is something like once you create the relationship between the tables, look here, in this case, we have created the relationship between these two tables. So the product key from the dimension table product, the product key of this table, right, is linked with the product key of the fact table. So here also you have a product key, and here also you have the region key. So here you have region key, and here you have region key. Okay, if you wanted to know the region name, by joining the region key from the sales fact table to the region key from the dimension region table, you can get the region name. Okay, here the relationship, only when you have the relationship you should be able to filter the data. So your dimension table region can filter the data in your sales fact table. Okay, the filtering is happening automatically once you establish the relationship between the tables. Okay, so hope you understood what is a dimension table. Dimension table consists of the surrogate key, which is nothing but the primary key. Along with that, you will have the descriptive information like product name, and here the category key and category name, and the region key, region name, and then the region name and the location, other details. Okay, and subcategory. Okay, the subcategory specify all the category. Along with that, category, subcategory will be there. Look here, when I say subcategory, ideally, right, it should have been related with this one, right? So the subcategory should hold the category also here. Category ID, the subcategory falls in which category ID? Ideally, this one supposed to be related. So this also, I just remove this one here. Okay, if you say ideally the subcategory should be linked up with the category table, because if you store it separately, how do we know the subcategory belongs to which category, right? So okay, this is a mistake, I remove it. Okay, in simple term, dimension table will have the surrogate key along with the descriptive information. This one will hold the fact table with the dimension table's key columns in it. Next, we will see the type of relationship. What are the types of relationship? As I told you, once you create the relationship between the dimension table or fact table, right, the filtering, it's nothing but filtering, right? So once you create the relationship, the filtering will be done automatically by Power BI. Okay. Next, we will see what is cardinality. What is cardinality? Before we proceed with understanding the filtering in detail, I'll show you with an example. How the filtering is happening once you create the relationship between the tables. Right now, let us understand the different types of cardinality. So, what is cardinality? In the case of database management system, right, in two different places use this term. The one is the one place, so we say cardinality is nothing but the unique values. When it comes to relationship between tables, it's something like 1-to-1, right? It's nothing but cardinality is nothing. When it comes to relationship or data model, it is nothing but relationship. Cardinal is nothing but relationship. So 1-to-1 relationship, 1-to-many, many-to-1, many-to-many relationship. There are 4 types of relationship. We can create it between the tables based on the nature of the table, right? So we decide when to create 1-to-1, 1-to-many relationship. What is 1-to-1 relationship? So this is the example for 1-to-1 relationship is something like an employee is owning a single office, right? An employee is owning a single office. An office can accommodate only one employee, right? That is the example for 1-to-1. For example, you have employee can have, let's assume that an employee can have only one office. Okay, so 1-on-1. So this side is 1. Each employee can have only one office, and each office can have only one employee. You just think that way. Okay, so in office also we have cubicle, right? So we have something called cubicle. So each employee can have only one office, and each office can have only one employee for 1-to-1. This is one example for 1-to-1 relationship. What is 1-to-many? A single employee can work with multiple projects. Single employees can work with multiple projects, and a car manufacturer produces many car models. A customer can, let's say you have a customer can order more than one item. So these are the examples for one-to-many relationship. Next one is the many-to-one relationship. An employee, right? So an employee multiple employees can work on a single project. Okay. More items ordered in a single order. Okay, these are the examples for many-to-one relationship. Any other example you can give it? Can someone give me an example for many-to-one relationship? Any examples? Okay, next one is many-to-many relationship. An employee can work on multiple projects. A single project can have multiple employees. This is the example for many-to-many relationship. And in general, many-to-many relationship, is not recommended. But in the real world, right? So when it comes to the business scenario, you will face many-to-many relationship also. So in that case, we need to address this many-to-many relationship in terms of introducing a bridge table. We have something called bridge table. Bridge table or link table, they use different terms. Bridge table or link table, something like that. Okay. So what do you mean by the bridge table? What do you mean by link table? We will discuss it as I move further. Don't worry. Okay, we'll discuss about that also. Okay. And the next one is we will see this is the employee. This is the example for many-to-many relationship. Next, we will proceed with understanding what is active and inactive relationship. This is very specific to Power BI. When it comes to active relationship in Power BI, it propagates filter to other tables. Right, so active relationship, it propagates filters to other tables. When it comes to inactive relationship, it doesn't pass filtering. First of all, what is filtering? I'll just go back here. See, once you create the relationship between the tables, right? So in order for the filtering to happen between the tables, you need to have the relationship. How do you create the relationship? So you need to create the relationship based on the common column between the two tables. In this case, I have taken two tables. The common column between these two tables are product number. You remember in Power BI, Power Pivot, I just go here. This is what the Power Pivot. If you click on this icon, you can see the data model. Okay, here I already imported these four tables. You know how to import the tables or data here. So I create the relationship between the tables also. For example, this is my sales data. Let's take this example. Okay, product data. So here, if you see, you can see one here on this side of product table, and you see star on this side of this table. That means there is a one-to-many relationship exists between these two table, right? So here each product. So one means each product, is appearing multiple times in the sales data table. Obviously, because in the order, right? So many customers would have purchased each product. So this is one product, or each product has been sold in many orders or many times. You can find multiple transactions for each product. If I want to create the relationship or link, this is called link. When I hover the cursor here, you can see the product number on the product data table, and then the big box sales data table got highlighted, the product NO. So when I double click on this, it will open up a dialog window. So this is where you can see. So here I created the relationship between these two tables using product number. Look here, you need to select this one, and you need to select the similar column here, product number, and then you click on OK. Before you click on OK, you just check the cardinality also. Cardinality is relationship, many-to-one relationship. Here the sales data, in this case the sales data I used it here. This is a many site because star is there, right? It's a many site because multiple transactions are there. Each invoice or each order, right? So, or in multiple invoices, we would have sold the same product many times, right? So here this is the many side and this is one side, and here many to one, and the cross filter direction is single. Cross filter, we started talking about filtering, right? So the product data table filters the sales table, in order to slice and dice the data there. For example, once here in this case we have created the relationship between the product and the sales data table based on the product number between these two columns, right? So now what happens is, behind the scene, for example, you wanted to know, or what happens is, the bikes, the product number is BI008. Since we have created the relationship between these two tables, it filters the corresponding bikes products in this table automatically. BI008. So what are the associated products that are there in this sales table? 2 records. If you want to see the total sum of sales for each category, what will happen is, for each category, so it starts with PS012, and then what it does is filters, or it finds out the associated product number from this table, from the sales table, and then it's kind of grouping the values only for PS012, and then it does the sum on the sales. In this, the second record, when it comes to second record, BI008, in this table, product table, this is the product number. What is the associated values that are available in the sales transaction table? Only those records will get grouped, and then it does the sum. If you want to find out the sum of sales, it does the filtering automatically. So that's the reason why I use this term. The product data table filters the sales table. Since you created the relationship, it does the filtering. The filtering happens automatically. Okay. Here you can see the solid dashed line here. So this is called active relationship. You can establish an active relationship between two tables. You can establish only one active relationship between tables at a time. For example, you have another column. Let's take, for example, I'm going to import another table here to show you this one. So we have something called active and inactive relationship. Currently, all these tables are having active relationship with the sales data table. But remember that you can create only one active relationship between tables at a time. You cannot, for example, you have another column, you want to create an active relationship with another column in this one, it will not work. You can create it, but by default that one will become a inactive relationship. I will show you with example. I just go and import these tables. I imported it from SQL Server. Now I import the date table from the Excel sheet. You can import the data from different sources also, JSON file, everything, and then you can create the relationship also. That is possible. Now I just select import, load the date data table. Fine. So here the date ID is the unique value in it. When it comes to data analytics, right? So the date table is very much important. But if you are working with a single table, you don't need a date table, but still it is highly recommended using a date table. I'll show you how to create the date dimension also, don't worry. So here already the data is readily available. I am just importing it. I'll just expand this one to see all the columns that are part of this table. Okay, here what I do is I create the relationship between the date data and the sales data table using the date column. Here what I do is I order date key is there. I select this one and directly drag and drop it to this one, order date key. So now the dialog box opened. We can check whether no, we are not creating a relationship between the correct columns, right? We are not using the correct columns to. So in this case, date ID. So date key, yes. So year, month, date, and year, month, date. Okay. So here in the big box sales data, we are using order date key and then date ID. So these two are having the same values in it. Hence, I'm going to click on it here. There are two ways of creating the relationship between the tables. One is you can drag and drop it. If you know very well the column names, right, between common column names between these two tables, right, in these two tables, then you can drag and drop it. See, in this case, what happens is there are there are some projects we worked. The common columns between the two tables are not in the same. The column names are not same. Okay, the common column between these tables are supposed to be date ID, right? So, but here order date key is there. Ideally, here also we should have had order date key, but here it is not. Here date ID. Usually in date table we use something called date key only. But here date key is not there. Date ID is there. The naming convention of the column is different here. So here we need to make sure that we are choosing the correct columns, between these two tables, and rest you don't do it. You don't have to do anything. Automatically it shows it's a many to one because this has many date keys, right? For the same date, multiple records will be there in the transaction table, whereas in this is a dimension table. The dimension table for each date, only one record will be there. For each month, date, year, right? Only one record will be there. So I just go and select it. Okay. So there are two ways you can create the relationship. As I told you, if you know the column names which you link between the two tables correctly, then you can drag and drop it. So in this case, I know very well the product number and the product key. I need to link it. So I just dragged and dropped it earlier. So now, when we did here, one second, one to many, right? So the relationship is one to many. This is one side, this is the many side. Okay, so the two ways of doing this, you just drag and drop the column if you know the column names correctly, right? So you can do it. Or else what you do is you go to manage relationship. What I will do is I just remove it to show you how to create the relationship using the manage relationship. In these circumstances, right, if the column names are not using the proper column names, better you can go to the manage relationship. Go to manage relationship. Here what you do is you can create the new, click on the new. So here the order date key, I'm going to select it, and date ID I'm going to link it. So there is a many to one relationship. Okay, I don't have to change this one here. Okay, it correctly identified it's a single one. Okay, fine. I just click on OK. Look here. This is another way of creating the relationship between the tables. Look here. Where is the date? This is the one, right? Second one. See, in the sales data table, we have used the order date key, using which we linked with the date data columns date ID. Okay, this is another way of creating the relationship. Either you can drag and drop it, or you can create the relationship between the tables using manage relationship. So now I just use the manage relationship to create the relation between the tables. It will take some time to create the link between these two tables. And once again, if you want to double check, right, you just hover the cursor on this link so that you can find out the highlighted columns in these two tables to make sure that you use the right columns to create the links between these two tables. Good. Fine. So next what I do is, next what we will do is, I was talking about inactive relationship. So now we create an active relationship between the date data table and this one, and other tables also we could see the active relationship, right? So supposing I want to create one more relationship between these two tables, date data and big box sales data. If I want to create it, how can I do that? Is it possible to do that? So if I see here, date ID is the unique key here. And what I want to do is, I want to create the relationship between date ID and the ship date key. If I try to do it here, so now I know the column names very well, hence I drag and drop it. So one to many, date data and big box sales data, fine. So it's one to many. It created one more relationship between the date ID and the ship date key. But if you see the link, it is a dashed line. The link now, whatever we created, it is a dashed line, right? The link appears like a dashed line, right? So it appears as a dashed line, whereas it's a solid line, which means this is the active relationship, this is the inactive relationship. So with this, we are able to understand very clearly, right? You can create only one active relationship between tables at a time. You cannot create multiple active relationship between the tables. The inactive relationship, it does not pass filtering. It does not do anything by itself. Only the active relation propagates the filters to other tables. What do you mean by propagates the filter to other tables? So like this, BA008, it automatically propagates this value to this table, and then associated records will be selected automatically. And similarly, right, here also the same thing, PA02, it goes each and every record, PA012, okay, so PA012 is there, all the associated values related to this product number will get filtered automatically. When it comes to second record, it picks up the associated records automatically. In simple term, in the product table, since you have the active relationship between these two table with the product number, it propagates the filters to the other table automatically, right? But whereas in the case of inactive relationship, it does not pass filtering. Supposing if this relationship is inactive, it does not propagates the filters to this table. Okay, but when it comes to real life scenario, we will have to establish multiple relationship between the tables, right? In the same table, I need to ship date key, and we have another date key column is there. I need to establish multiple relationship in real life scenario. We will have to create it. But at a time, you can create only one active relationship. Rest of them will be inactive relationship. Is there any way I can enable this inactive relationship to pass the filters or propagate the filters to the other tables? Yes, it is possible. Using DAX function, we can do it. We can enable this inactive relationship temporarily using some DAX function. We have something called use relationship. Use relationship. Anyhow, we'll discuss this later point in time. At this moment, you just keep that in your brain that only active relationship propagates filters to other tables. Inactive relationship does not pass filtering. Okay. So it requires the inactive relationship needs a special treatment to work. That we will see it later. At this moment, hope you understood what is filtering. Only when you create the relationship between the tables, especially the active relationship, helps us to pass or propagate the filter to other tables. Okay, and next one is we have something called role playing dimension. We discussed about dimension and fact tables. We have something else called role playing dimension. Before I jump in, let us go ahead and create one visual here. What I do is I just instead of using country, I just remove this. We'll see what is the month wise, or I'm going to say fiscal year wise. This is okay. So we can see the year wise total sales. We can see the year wise total sales, and here I just go and see in the product table. Okay, let's go step by step. So this is my year wise sales. What I do is I just go here, and then I just delete the relationship between these two tables. So in this case, what happened, I just dragged and dropped the year from this date data table, and then sales amount from the sales table. Okay, so it does the filtering correctly. Next, what I do is I just go here, and I'm going to remove this relationship. If I go back here, look here, it repeats the overall sales for all these years, 2017, 18, 19, 20, 21. Since I removed the relationship between these two tables, it is not doing the filtering. You might be asking, we have inactive relationship, but still it is inactive, it is not active relationship. Okay, but I removed the active relationship between those two tables. It is not doing the filtering. The date dimensions, right, year column, the year column is not filtering the sales amount from the sales table. In order to do the filtering or propagate the filter from your year table to sales table, you need to have the relationship, active relationship. I'll show you when we can use inactive relationship. One second, I just this is the one, right? So date ID and this one, because of the naming convention issue, better we can go and create the relationship here. You might be asking this one, can I do I have to choose the many side first, and then do I need to choose the one side next? No, you can choose it in anything, in any order. For example, here the date data is one side and the transaction is a many side. Okay, you can select a big box sales data here, and you can select date data also here. Okay, here the order doesn't matter. Okay, you can choose whichever table that you wanted, but make sure that you are creating the proper relationship. Here you have the date ID, so this is the date ID, and you can find out. So here I can use the order date key for the time for the demonstration purpose. I'm going to use order date key. So these values are matching here. So even you can see due date key and ship date key also, which I will come back later. Let's go step by step. So now we informed Power BI, hey, use these two columns to create the relationship between these two tables. Create the link. Look here, it got created. Fine. So I just say close. Let's wait for some time. See, it automatically created the link between these two tables. Okay, and if I hover the cursor here, date ID and order date key, these two columns got linked up. Fine. Next, what I do is, so now we'll go back here and see here the filtering is happening now. Since we created the relationship, it is the date table is filtering the data from the sales table correctly. Okay, and next what I do is, so now we created a relationship between the order date key and the date ID in this table. So in that case, what happens? It performs the, or it finds out the total sales by year, right? Total for each year, what is the total sales? So for this year, this is the total sales. For year, this is the total sales. So this is the ordered date, right? The sales amount based on the order date. Sales amount based on the order date. So you all know very well. So when we order any product on the e-commerce site, we make the payment on the same day. Some cases, cash on delivery. Upon receiving the product, we make the payment. So the sales is the payment, right? The collection is not happening on the same day for some orders. But there are some orders, the collection money, right? We are collecting the money on the same day. Okay. So order, based on the order date, see, we filtered the order date here, right? So this date ID is filtering the order date, which means we are interested in seeing the sales amount or the money we collected on the same day. You just think that way, okay? The order date itself, they made the payment using the credit card, okay, or something. So the how much money we collected on the same day by each year, if you want to see it, you create the relationship between date ID and order date key. Okay, but I need to see the the year wise how much sales amount we collected after during shipment, right? After or at the time of shipment, how much money we collected. How do I see that? At the time of shipment, let's say we are delivering the product to you today, it's a cash on delivery. Upon receiving the product, you are making the payment, right? So in that case, how do I find out, right, how much money we collect, or the money we collected during the ship date? So in that case, we need to create the relationship with date ID and ship date key. But here we created it already, but it is inactive relationship. It is inactive relationship. But it will not propagate the data here, right? So it will not propagate the data because it is an inactive relationship. There are two ways we can treat this one. Okay, how we can treat this one, right? We can enable the inactive relationship temporarily using DAX function. There is another way of doing is we can create something called role playing dimension. What do you mean by role playing dimension? What I am going to do is I am going to just copy paste this same table. Okay, instead of here doing it here, I just the model, we cannot do it. 1 second, I just go here. Okay, instead of this, what I do is since I have the luxury to import it one more time, the same dimension I'm going to import it one more time. The date data one more time I'm importing it. So duplicate. Look here, the duplicate of the same table got loaded here. We duplicated the same thing by importing it the same table one more time. So what I do is I just rename this one for our understanding. I'm going to say this as ship date, something like, okay. So I'm going to remove this inactive relationship here. I just imported the same file again, but I renamed it with some meaningful name, right? Ship date data. Both these tables having the same data in it, okay. So here what I do is I create the relationship between the date ID and the ship date key here. Here ship date data, date ID, and the ship date key. Yes, it's correct only. So I just create the relationship between these two. Done. Now what I do is I just go here. In this case, I just remove this one. This is from order 1 and this is from ship date. And here I just say, I just select here. And here 105. Okay, here ship date data, right? And here I just used the year here. Okay, there's something wrong with this one. One second, let me just use this one. Two 2017 and 18. Full date here. Okay, let me use this one. And the ship date key I'm going to use ship date key and ship date date ID, and that one is correct only, right? Is correct. And here it is not doing the filtering correctly. I think sorry, here I need to use one second. Here I need to use this one, right? Order date key is linked with that one. Or let me just 1 second, I just try with this here. Okay, the here one. Two 2017-18. Let me do one thing. I just go here and for the time being I just delete it. It is doing it correctly here, right? So what we will do is, yeah, so if you see the year wise, it will be correct only. Yeah, now I got it. So now what I will do is I just select some other column here, and I used to go and with the regions, the group. Yeah, I just select group here. Yeah, because the relationship is not there. 1 second, I just go here. Now it should show correctly. 1 second, I just so 10374. Even then it is okay. What I will do is I will just use some other column, consumer key, and in this one I use the date data here. This is my order date. Yes. One 178. Okay, the data is something wrong with the data here. Maybe the order date, right? So the order date and ship date more or less same, it seems. Okay, I will probably show you with other data. We'll test this with some the DAX measure. What I will do is I just, at the time being, let me do one thing. This is for the sales amount in this one, and the ship date year, and then regions we grouped it, and here we have used the order date year, the year from this, and then we have used sales amount, and then you use this, and the values, everything remains same, right? So yeah, let me just go and do something else. I just check a region here. And here also I just do the region here for this. I just select region. So this is Europe, right? So Europe 97 496 80 686. There will be a subtle difference between these two. Nine seven four nine 80,686. North America 22,022 1344 1870. So there is a problem with this data. Let me, because the relationship, everything is correct. Otherwise it will not allow us to display it in the visual. So the date ID and these two are correct. Ship date key and this one and this one is same. Let me do one thing. I'll go to this granular level, country level. Country level, 1 second. For each group we have only one here. Okay, here also it will be the same thing. I just do one thing. I just sort this one. So Europe 97, North America. We don't see any difference between the. Does that mean everyone made the payment on the same day itself? 1870, 15 lakh 24. Okay, let me just select this one. We don't have any other. Full date. Okay, full date, hierarchy. We'll select this one. We'll see. All the values remain same, right? It is not North America 15, 13, everything. There is a subtle difference between these two. And 568 65 5154. Okay, we don't see any data related to the shipment date. Okay, on the shipment date, whatever the money we collected, it is not, we don't have the, I think something wrong with the data here, because I've used some other data. Let me show you. We will test this one with inactive relationship. Let me just go ahead and delete this one. As I told you how to activate the inactive relationship using DAX function. We'll see. Anyhow, you don't have to know the DAX function now. I just for the testing purpose I'm going to use it here. I just select this one and I create an inactive relationship between this and my sales ship date key. Date ID and ship date key, correct. Now we have an inactive relationship between these two tables. Fine. So I'm going to activate that one now. So I'm going to ship date key, and then here data table, ship date data, ship okay, here we have date data only, right? So we have created inactive relationship, date ID. These two are the common column between these two tables. Okay, now I just select this one. Here I just select the group from this table, regions data. One lakh 78. Okay, let me do one thing. I just remove the region is not required. Yeah, then something wrong with the data here. Okay, I just recheck the data. Okay, I will use some other data for the demo purpose. Look here. So what here I did, I just created a measure. The measure name is measure. Here you do the total sales, compute the total sales, for these two relationship. Okay, so the sales, this is my sales data ship date key, and then date data date ID. So you create the link, enable, activate the inactive relationship during the course of this calculation. So that is what it says. Use relationship, what it does is, this function, this is a DAX function. What it does is, so here we need to specify which tables, common columns that needs to be linked up here. So the date ID and ship date key we have specified correctly here, and we are doing some sales. For the ship date, what is the total sales by ship date, right? Ship date, that's what we are seeing it here. But here we have we specified the years here, 2017, 18, everything is correct, but it is not doing correct. There is something wrong with the data. That means the ship date, whatever the sales happened, right, the money, see, according to this, the money was not collected on the ship date. Everything we collected on the order date itself. Something wrong with the data. At least the measure should show correctly. In order to create use relationship, you need to have the relation. We created the relationship here between these two tables. Okay, inactive relationship is there correctly, but something wrong with the data. Anyhow, we'll test it, and then I'll come back in the tomorrow session about this data related issue. So now you understood what is direct relationship, what is indirect, what is active relationship, inactive relationship. Okay, the active relationship, automatically it should propagate the data, but without relationship it was repeating the same data again and again, right? So that is the problem with the not having the relationship. Okay, so now we tried creating more than one relationship between these two tables. But if you try to create multiple relationship, creating multiple relationship is possible, but you can have only one active relationship at any point in time. At a time you can have only one active relationship. So the rest of them, whatever you created, it's all inactive. So in order to enable the inactive relationship to active, we have a DAX function called use relationship, using which you can enable the inactive relationship. Okay, in this case, the date ID and ship date key, whatever the relationship we created, is inactive. The prerequisite is first you need to create the relationship in your data model. We already created it, but here also we specify. You need to specify it here also, and we have something called calculate function here. The first argument we use sum of sales amount. It is everything is correct. Only thing is something wrong with the data. I will just check the data and I will correct it. Okay, tomorrow I will correct it with some other data, because if I start check the data, it will take more time. I'll just check it, because there are two approaches to deal with this. See, one is first understand the concept now thoroughly. So one is to enable, instead of having the inactive relationship, we can create the duplicate of this table here, and then we can create the relationship between this date ID and this sales date ship date key, and here this date ID is linked up with order date key. I just, anyhow, in both the cases it is not working, something wrong with the data. Here this date ID and the ship date key. Since we are directly connecting to these two tables, we don't have to create any inactive relationship in this case. Look here. By duplicating this date data table, we avoided using the inactive relationship between the tables. So in this case, what happens is, right, so here we have direct active relationship between the date ID and ship date key. Fine. So here we don't have to. In this case, we have eliminated the necessity of having the inactive relationship between these two tables by creating this table. But the filtering is not happening correctly. I think I need to check the data. I will come back to that. But this is called role-playing dimension. A single dimension playing multiple roles. Using this table, right, using the same dimension table, we can filter your sales data based on the ship date key. And using this order data table, we can filter your sales data table by order date key. That is the idea. Since the single dimension plays multiple role, in this case, filter the sales data by ship date, and in this case, filter the sales data by order date, right? It is playing the multiple role. Same dimension plays the multiple role, hence we call the role playing dimension. So this is one way of filtering or preventing the inactive relationship. But now the question is, in this case we have three date columns are there. Ship date key, due date key is there, and then we have ordered 3 date columns are there. For 3 date columns, if I want to filter for these 3 different date columns independently, so in that case I need to have one more dimension table. The same table I need to copy paste it. I need to create the relationship between due date key and this table's date ID. Now the question is, won't that consume more space, or the storage, right? Storage, it will not consume much space. Okay, instead of having the inactive relationship, you can have the role playing dimension. You can create more than one table also, because in general the date table will not consume too much of space, right? Maximum, for example, you are storing from 2015 to 2021, right? So it will not consume too much of data in it compared to your sales data. Sales data will have millions and millions of records. Let's say you have 50 millions of records, right? So in that case, compared to this, it will not consume too much of it. This is one way of filtering or creating active relationship, multiple active relationship, right? So this is active relationship, this is also active relationship, right? So to avoid using the inactive relationship, or if you, the other way of doing is, I don't want to have the duplicate of the date dimension again. So, but I need to filter the sales data using the single column, right? So with the 2 different columns here, right? So I want to filter the sales data for 2 different columns, right? You need to create the inactive relationship only. Okay, So in this case, the active relationship is already we created, but if you want to filter it based on the sales date key and you want to do some kind of slicing and dicing on your sales amount, you have to create inactive. This is another way of creating the relationship. Either you can have an inactive relationship. If you want to have more than one relationship, you can create inactive relationship, and temporarily you can activate it by using the DAX function. That's what we already, so to activate this temporarily, right? So we use a DAX function. The prerequisite is first you need to create the relationship between these two tables, right? With the appropriate relation, date ID and ship date key got linked up, and then date ID and order date key got linked up here. Order date key and ship date key, yes, correct only. I think something wrong with the data, because the filtering and all we did it correctly, right? So even the measure also we tested it, and only thing is, let me just check with quarter. Sometimes what will happen, the granular data, when you use it, you can find something. Let me just, instead of year, I just last attempt. Here I use date data, right? So okay, here let me just use ship date. Sorry, not this one. Measure. Group and measure value, and I'm going to remove the sales amount. Here the same thing only. Here I'm going to use the date quarter only. So here quarter. It shows same value only. Okay, here 38. So North America, it shows 3880. Yeah, I got it. So North America 6058, and let me just do one thing. I'll sort it based on the quarter. Okay, here I just sorted based on the quarter. Quarter 2 North America. See, when you do the quarter wise, when you get into the granularity at the quarter level, we are able to make out, right? 4069 and North America, yeah. So it's not the problem with the data. We should have drilled down to this level. Okay, now since I used quarter 2, look here. So this is the one is related to the measure. So this table, the sales table, now got filtered by the ship date. Total sales by quarter by ship date. This is the thing. Okay, the overall total will be same. Okay, overall total will be same, but this one, right? This is, see, there is a subtle difference. 38 North America. Now I got it. So 178. Now it's working correctly. 60 58. Correct. Got it? So now if you wanted to have both of them in the single table, see, when you simply compare the overall total with this one, it will be same only. But somewhere, right, in some region, the money collection date and the money collected date is sometimes, right, we would have collected the money on the shipment date. Sometimes we collected the money on the order date itself, right? So when you drill down at the quarter level, now we are able to find out. If you want to include both sales amount by order, sales amount by sales in the single table, I just bring in the measure here. Look here, in quarter 40 is 69, and here, okay, and 41, fine. 1,78,000 and 60, and look here. If you see quarter 4 in North America, right? So quarter 1, quarter 2. So in quarter 2, this is the sales amount by order date, sales amount by ship date. Okay, and here quarter 3, quarter 4. In quarter 4, we could see that this money is more than this one, right? The ship date on the collection on the ship date is more than the collection on the order date. It's correct only. It's something like this. See, for example, to explain you all, to understand it clearly, I'll just show you with one example. For example, your order date is on 10th Jan. Your order date is on 10th Jan 2022, and this is my order date, and on this date no payment. Okay, they ordered on this one. This is a product A, and 12th Jan 22, the same product A. This is my order date, and this is my ship. That's what the data, you need to test it correctly, otherwise you'll land up some kind of confusion like this. Product name, but if you see order number A001, the same order number, shipped, the order date is same only, 10 Jan 22, and then the ship date happened on, let's the 13th Jan 2022. You see the amount column here. Here we did not receive the money on the same day. On the shipment date only we received it. So let's say you have received 5,000, right? There are some cases, order number is A002, and 8th Jan 22, product B, ship date also on the same day. This is what I am talking now. So here you have something called 2,000. Okay, that is what we are saying. So if you look at instead of saying that, right, let's say this is you just think this is quarter 1, or let's say this is a classic example. 31 Jan he ordered the product A, but in 3rd February we delivered it. Same order, but we received money on the, this is same, this one, suppose we shipped it on 3rd February. The order date remains same only here. We did not make the same day delivery, right? So the A001 we did not, right, we delivered it on 3rd February. Okay, hence on that day, since this order is a cash on delivery, they made the payment only on the shipment date. Okay, so for the January month, fine. So this is similarly, right? So that is the reason why it shows the difference here. So look here, the quarter 1, it's same only. Maybe on the same day they would have made the payment, but in quarter 2, the order day, right, the shipment, the collection which we made it on the shipment date is only this much, and here, so overall it tallies. It is tallying it. The sales amount by ship date and sales amount by by order date, right? So sales amount by order date. So that's what we can see it here. So now with measure we are able to do it, right? So since there is a confusion with the granularity level, so we looked at the high level, year level, right? Even with the quarter level itself, most of them are matching. So now what we will do is we will try with the, now I am going to remove this, we will try the same thing, okay, same visual. The date ID and ship date key. Good. Because we removed the relationship. Now I am not going to use the one second, this is the one, right? So here this is the order date, filter by order date and region, the sales amount, this is fine. And now I just come here, this is the shipment date, quarter. Yes, quarter one, correct. Now it is doing the, because of, yeah, this is data problem. It's not it's kind of a data problem, right? We if you look at the year level, so in the hierarchy, year, quarter, month, day, right? So year level, it is showing correctly. For example, if you add the quarter one, quarter, all these quarter, right? 4 quarters in North America, it will be same only, isn't it? But only when you drill down to the quarter level, you will get to know, what is the difference in the collection amount, right? Or the money we collected. So now it's showing correctly. For example, this is the, see, if I select this visual, it automatically, it automatically shows the columns that we used it in the tables, region data. And look here, the date data is nothing but my order date, right? So we are filtering, see this date data, date key and order date key we related, it is doing perfect job now. So 178, so 38, look here in quarter 2, we did not, this is the shipped one, right? Yeah, this is the shipped date, shipment date we received 38 lakh. Okay, and here 60, 58, and look here we received more on this month. So that is what we says. So sales amount by ship date, sales amount by order date, it is filtering it correctly. Only thing is we did not drill down to this quarter level. Now we are able to drill down. So now we are able to achieve the same thing using the role playing dimension. This is the role playing dimension. Now you understood, right? So you sometimes it will confuse the data, but it is good. You can drill down, right? So even at the quarter level, if you cannot see any difference, probably you can drill down at the month level to see it. So here I did not use any inactive relationship. See, if the project sponsors, if they demand, we don't want to have multiple date dimensions, we don't have the duplicates, right? So then you can create the inactive relationship. So with this or date table, this date dimension will filter the order date key, and also if you enable the inactive relationship between date ID and the ship date key, you can filter the date ID from this table to this ship date key. Okay, that is also possible, but that one is possible only when you use DAX function. Using a DAX function, you can temporarily or till the duration of the calculation, it will enable the inactive relationship as a active relationship. Once the computation has been done, it'll get reset. Okay, it will become inactive. It is something like that. Hope you understood. Sorry, I should have drilled down to the quarter level. There is nothing wrong with the data. Everything is correct, but only thing is the drill down. It's working perfectly now, right? So even with DAX function and without DAX function, so without inactive relationship also it is working fine. Since this dimension plays multiple role, the same dimension plays multiple role, we call that as a role playing dimension. It is as simple as that. So hope you understood this one, right? Any questions? Okay, since you don't have any questions, we will continue tomorrow, same time. It's already 7 o'clock. Fine, I'll upload the video. Okay, fine, thanks. See, when we drill down further, we are able to understand, right?